Okay, so in this video, we're going to look at the binomial distribution again. Go look at the other two videos if you're not sure what it is, or if you want to see some examples of how to use it. In this one, we're going to look at some key features or key properties, notably the mean, the variance, and standard deviation. Now, the mean of a binomial distribution, or any distribution for probability, is also called the expected value. So if I did a trial this many times, how many times would I expect a success to occur? For the binomial distribution, this is calculated simply by multiplying the number of trials by the probability of success. And it kind of is something we've done a lot over the years anyway. We kind of know that. If I roll a dice 60 times, how many ones would you expect? Well, we know the probability of getting a 1 is 1 over 6, so we'd expect about 10. Well, that's n times p. We've been doing that for years. It's just that we haven't formalized it with a binomial distribution. Okay, so EX like that is known as the mean or expected value. It can also be given this symbol here. Now, this symbol is mu. I don't know how you spell it, but it's the Greek letter mu. But anytime you say E of X or mu, that means the mean, NP. Well, it's NP for a binomial distribution at least. Now, the variance describes the spread of the data. How far spread out is your data? That's the variance. And that's VAR, so variance of X, or it's given by this thing here. And this is sigma squared. Now, sigma is another Greek letter. It's always going to be given as sigma squared being the variance. And to calculate the variance in the binomial distribution, it can be calculated differently for other distributions, but in the binomial, it's calculated by NPQ or NP1 minus P, where P is your number of successes. So is your probability of success. 1 minus P is your probability of not success or failure. And N is the number of trials. And notice that there is your mu. So mu times Q gives you the variance. The last property is a standard deviation of X. Now that's given by a sigma by itself. Not sigma squared, just sigma. And that's another measure of the spread of the data. And that's going to be fairly important for us when we get to normal distribution. But the sigma is quite helpful. It tells you how far it is spread from the mean specifically. And it's just calculated by finding the square root of the variance, or NP, as the same as they were before. Now, something key to note is that the probability of landing of the variable being somewhere between 2 standard deviations below the mean and 2 standard deviations above the mean is approximately 0.95 for something like this. That's kind of important to know. It comes up a bit. It comes up more in the normal distribution, specifically when you're doing a 95 rule. We'll get to that later on. But with a binomial distribution, it's going to be approximately 0.95. So let's get to a couple examples. So here we go. We get a bag containing 4 blue balls, 3 red balls. It's the same example as before, but this time we're doing expected numbers and variance and things. It's selected, color noted, returned. Calculate the expected number of blue balls that are selected. Mu. So mu, we know, is given by NP. Now N is the number of trials, that's 5. And P is the probability of success. In this case, it's going to be the probability of getting a blue ball, which is 4 over 7. So that gives me 20 over 7, or it gives me, if I round it off in decimal places, 2.857. So if I did this trial 5 times, I'd expect to have 2.857 balls come up for blue. Now, of course, that doesn't make any sense in one trial, one experiment. Do one experiment, do it 5 times, I'm not going to get 2.857. But essentially what's happening is if I do that trial again and again and again, so the experiment 5 times, another 5 times, another 5 times, another 5 times, over and over and over and over, long term across all the different experiments, you're looking at an average of 2.857. On a tech-free exam, you'd leave it as 20/7. They wouldn't ask for decimals from that point. Variance. The variance is given by sigma squared. So sigma squared we know is NP 1 take P. N is 5. P is 4/7. So 1 minus 4/7 goes there. And that's the same as doing 5 times 4/7 times 3/7, which altogether you could write as 60/49, and that would be how you'd leave your answer as a tech-free exam. But in a tech-enabled exam, you would then write it as 1.22. 1.224 to 3 decimal places, that is. Final one of our example here. So the last one, standard deviation, that's your sigma. That's the square root of the variance, which is square root of sigma squared. So square root of 1.224, and that gives you 1.107. It's your standard deviation. So like I said before, if I had the mean of 2.857 and I took away 2 standard deviations and then had the mean added 2 standard deviations, that would give me the probability of somewhere between 0.643 is less than 5.071. If I was to calculate that probability, that's going to be approximately 0.95 or 95%. Now these values, of course, we're dealing with whole numbers. You can't have 0.643 if I was trying to calculate this. So this would be the same as getting between 1 and 5, because we only have 5 trials and you can get up to 5. And so 5 is the nearest whole number inside that area, and 1 is the nearest whole number inside this interval. So these two are equivalent. So if you had to calculate it on your calculator, you would have to use this. Otherwise, it would not work. But that'll be approximately 0.95. They're the most straightforward ways to calculate it, but you can also get given something like this. The mean of a binomial distribution is 3, and the variance is 2.1. Find the number of trials and the probability of success. So I know that X is binomially distributed, N and P. I don't know N, don't know P. I've been asked to find it. So let's do that. What I'm going to do is remember that E of X equals 3, but we know NP equals 3. That's what E of X is. We're told that the variance is 2.1, but the variance is calculated as NP 1 minus P. So I'll put that equal to 2.1. Now if I go from there, I can notice hopefully that we actually have NP there and NP there, which means those two are the same value. So what I do is I replace NP with 3. So we end up with 3, 1 take P equals 2.1. Divide by 3 to get 0.7. And if you solve that, you see that P is 0.3. Therefore, to find N, you now substitute it back into there. Now, N times 0.3 equals 3. Well, what times 0.3 gives you 3? Well, that'd be 10. And that would be how you'd find the number of trials and the probability of success. And that is how you use the equations for mean, variance, and standard deviation for the binomial distribution.